Hello, this problem has been asked in GATE 2023 and the problem belongs to control system and this problem is from the how we can find the transfer function, the basic of signal flow graph and the block diagram reduction. So before solving this problem, we will having quick recap of the signal flow graph. So the term block diagram means that it is a pictorial representation of the functions performed by each element, while the signal flow graph represents the graphical representation of the relationship between the variables. So the basic difference between block diagram and signal flow graph is that it is block diagram is pictorial representation, while the signal flow graph is a graphical representation. And in this question, we are having given the pictorial representation. And now from the signal flow graph, we can find the transfer function or the gain using the Mason formula. So the relationship between the input and output of a SFG is given by the net gain between the input and output nodes is known as gain. So this is the transfer function. We can find the Mason's expression and transfer function or gain of the system will be summation from k is equal to 1 to k pk delta k divided by delta, and this expression is very important for finding the transfer function of a block diagram given. Now the terms used in the express Mason's gain formula, we can represent T is the overall gain of the transfer function system, pk the path gain of kth forward path, while delta k is the value of delta associated with kth path. In this the gains, whatever the gains we will take, that is not touching with the kth forward path. So remember, in the delta k, while calculating delta k, we will take the gain values which are not touching with kth forward path, and delta is the 1 minus sum of loop gains plus sum of gain products of all possible two non-touching loops minus sum of gain products of all possible three non-touching loop plus so on. So minus plus terms will come just in sequence. So remember this also. Now coming to this problem. So we are having given Rs is the input and Ys the output. And these are the gains values 2, 3, 1 is 1, and these are the summation blocks represented. First we will convert this block diagram into signal flow graph. So R we have taken, and this is the gain 1, and this node is coming where two paths are coming out. So one path is having gain 2, another path having gain 3. So two paths are coming from this node, and again 2 is coming to the summation block. So this node is represented as summation block, and 3 is going to the next block, next node, that is also summation block, and in between that 1 divided by s is the gain between the two summation block. And again this summation block is going to the output be represented as 1, and here is a feedback path having gain 1 is coming to the summation block. So we have taken this as like this. So one is this feedback path having gain 1, we just add it to the summation block. If this having negative feedback path, then we can represent here as minus. Now this output from this where feedback is coming, we take it as 1 gain, and output we get by. So this one is by. For applying the Mason's gain formula, we will find the all the terms. So delta will be 1 minus sum of loop gains. So there is only one loop is forming. We can see that that is closed loop 1 divided by s into 1 into 1. So it will be 1 divided by s. So 1 minus 1 divided by s, and no other loop is forming. So the next possible terms will be all 0. One loop is forming, so we can write delta is equal to 1 minus 1 divided by s. Since no other loop is forming, so other terms will be 0. And now we will find the forward path gains. So there are two forward path gains here, P1 and P2. P1 is this straight line 1 into 2 into 1 divided by s into 1 into 1, that will 2 divided by s. P1 will represent first forward path, that is 2 divided by s, and second forward path in which this 2 and 1 by s is eliminated. So second forward path will be 1 into 3 into 1 into 1. So P2 will be 3. Forward path means that is connecting the input and output. So that will be forward path. Now we will find the value of delta associated with forward path. Since this loop 1 divided by s is touching with both forward path, so delta 1 and delta 2 will be 1. So another terms will be 0. So just represent delta 1 and delta 2 as 1. Now applying all these values in the transfer function, we will get like this. Transfer function is equal to by s divided by rs is equal to p1 delta 1 plus p2 delta 2 divided by delta, and we have found out this p1 as 2 divided by s, delta 1 is 1 and p2 is 3 and delta 2 is 1, and delta divided by delta is 1 minus 1 divided by s. So we will get 3s plus 2 divided by s minus 1. So we have finally got the answer for this problem. So this we have found out using the signal flow graph. Now we will see the short trick how we can found this by the second method. Usually we apply directly this method in the block diagram, which is simpler one. We cannot apply this second method in the complex system. If we are having some complex block diagram, always go through the signal flow graph. Since this block diagram is very simple, we can also write the values at all the points and we will get the final answer. So here RS is the input and 2 is the gain. So here at this point we will get 2R as the value, and here we will get 3R values. Now this is feedback path having gain 1. So this here we will get by, and after summation we will get the values as 2r plus by here after the summation block, and 1 by s is the gain value. So after that we will get 1 by s into 2r plus by, and 3r is coming from this block, and this is whole is coming as by s. So we can write y s is equal to 3r plus 1 divided s into 2r plus by, and on simplifying this we will get this expression. So this is quite simpler one, but I always advise that whenever the system is block diagram is simpler, then you can apply this method. When the block diagram is complex, then you always try using this signal flow graph. So the correct answer for this problem will be B. Thank you.